Heat moldable resin and carbon fiber shreds are mixed into a container. They are then poured into a rotating aluminum mold to ensure an even distribution of material. When the mold is nearly halfway full, aluminum cores are inserted into the mold to ensure that the assembly will not overheat and deform. These aluminum cores serve as an effective heat sink for the upcoming pressing process. When all the cores have been placed, more carbon fiber is filled in on top of the cores. Here, a roller levels off the top of the material. The mold is then covered and sent to be pressed. 20 tons of pressure is applied to the mold as it is heated to 400 degrees Fahrenheit. This intense pressure and heat compacts the carbon fiber and melts the resin into plastic. After this process, the mold and part are then water cooled for 5 to 8 minutes. When the part and mold have been cooled, the aluminum cores are pulled. Here, an automated system can be seen checking for remaining cores. After the check has been performed, the top and bottom sections are then separated and the part is released. A CNC machine is then used to drill guide holes and smooth out rough edges. After this, the parts are heated for 2 days to 1800 degrees Fahrenheit, where the plastic turns into carbon.
After being cooked for 2 days, the disc is placed into a crucible and mount. A funnel is then inserted into the center of the brake disc, where a ceramic material is poured. The crucible is then loaded into an oven for 24 hours and approaches 3000 degrees Fahrenheit to melt the silicon into silicon carbide. Using low-level suction, the liquid silicon is drawn into the disc ring. A computer-controlled process drills mounting holes into the brake disc. The discs then receive a coat of protective paint to shield the disc ring from oxygen and prevent oxidation.
The equipment needed to manufacture brakes is a two-sided aluminum mold that will be filled with a carbon fiber mix, aluminum core heat sinks that will let heat dissipate from the mold, a 20-ton press, a cold water tank, computer-aided measuring devices, a CNC machine, an 1800 degree Fahrenheit oven, crucible and mounts, a funnel for silicon, a 3000 degree Fahrenheit oven with suction to draw the silicon into the disc ring, a painting chamber, and a paint curing oven.